Hi, folks. Welcome to 8.1, the law of sines. And so we're going to take this section and break it up into 3 different videos. And we'll get started with the first one right now. So we've learned quite a bit about sine, cosine, tangent, and even some things about how the sides of the triangle relate to each other, and maybe even how to find the area of a triangle. But one of the things I want to make really clear right now is these things that we've learned are only for right triangles. All right, and that's pretty limiting, right? Because as soon as we have something that's not a right triangle, we can't use these anymore. All right. But what we're going to talk about in 8.1 and actually 8.2 is we're going to expand our understanding to all triangles. All right, so it doesn't even have to be a right triangle anymore. And the rules that we're going to take a look at are law of sines and law of cosines. And then in 8.2, we'll take a look at area of a triangle where it's not even a right triangle. Okay. All right. So let's get started. We're going to take a look at law of sines, definition, and derivation. Okay. So here's our law of sines. You look it up online or in any textbook, and it'll tell you something very similar to this, that in triangle ABC with angles A, B, and C, and opposite sides, little a, little b, little c, okay, the following equation is true. Sine A over A equals sine B over B equals sine C over C. Now, I just want to make it really clear here that the angles that we have, those are all in uppercase letters. So angle, angle, angle. And that all of the sides that we have are lowercase letters, little a, little b, little c, and we have little a, little b, little c. Okay, so if you were someone who writes without a lot of distinction between uppercase and lowercase letters, it's going to be really important here that you have an uppercase A and a lowercase a, an uppercase B, a lowercase b, and an uppercase C and a lowercase c. All right, so this is the definition of the law of sines, but where does this even come from, right? We're sort of at a point in our mathematical career where it's kind of important that we start looking at where these formulas come from, right? So what I'm going to do here, I'm going to go ahead and sketch a triangle, right? And I'm going to make sure that it's not a right triangle. Right? And I'm going to label this with a capital A for that angle, capital B for this angle, and capital C. All right, so let's just go back and highlight these correspondingly. We've got angles here. And then I'm going to label the sides with the lowercase letters. So little a is going to be directly across from angle A. So I'm going to put little a over here. Okay, so little a. Same thing, little b is going to be directly opposite capital B. And little c is going to be opposite of angle C. All right. Now I know uppercase C and lowercase c look pretty similar, but let's just make sure to make one bigger than the other. Okay. And so we've got a side, and a side. Okay. So what I'm going to do here is I'm going to go ahead and I'm going to draw the height of the triangle as it comes from angle C. All right. So I'm going to try really hard to get this so that it meets side C in a right angle, okay? And because this line that I've just drawn meets side C at a right angle, I can label this the height of the triangle. Okay? So I'll call that little h. All right, now I've got 2 right triangles, all right? So I've turned this single triangle into this right triangle, the one in the red. And then on the other side, I have another right triangle, okay? And so what I'm going to do is I'm going to take the first triangle, all right, and I'm going to go ahead and find sine of A. All right, so and let's maybe add some color to this in this green, whoops, in this green triangle here. We're going to go ahead and use that to find sine of A, all right? And so sine of A, we know is the opposite over the hypotenuse. So opposite is H and hypotenuse is B, all right? So H over B. And this comes from that green triangle, okay? Now I'm going to do the same thing on the other triangle, and let's give that one a color as well. Maybe we'll go with a red triangle. So here to here to here. All right. And in this triangle, if I found sine of B, I would say opposite over hypotenuse or H over A. Okay, and this comes from that red triangle, right? So I've got sine A and I've got sine B, but both of these equations have an H in them, right? So here's what I'm going to do. I'm going to do a little bit of algebra. I'm going to take the green equation and I'm going to multiply both sides by B, and I'll get H equals B sine A. And if I do the same thing in the red equation, I multiply both sides by A, I'll get A sine B equals H. Now check this out. A sine B and B sine A, they both equal H. So what that means is I can actually set them equal to each other. B sine A equals A sine B. All right. And as mathematicians, we really like to clump things almost by letter. So I'm going to move the little a to the left-hand side by dividing it. And I'm going to move the little b to the right-hand side by dividing it. And when I do that, I get sine A over A equals sine B over B. Okay. And so here we'll see sine A over A, sine B over B. And if we go back to our law of sines, we have exactly 2 of the 3 pieces of the law of sines, okay? Now it turns out that if we do the same thing, but maybe we draw the height to little b, okay? So maybe that looks something like drawing the height to little b. Or if I do the same thing where I draw a height to little a, maybe that looks something like that, okay? And I go through the same process again, I'm going to get sine A and sine C, or I'm going to get sine B and sine C, okay? So basically, when we repeat the process, we'll end up getting the entire law of sines, all right? So that is where it comes from, okay? But now that we know where it comes from, before we do some examples, I want to review some really important things on the unit circle, all right? So we've only taken the top half of the unit circle, and the reason being that we have we've got 0 degrees, and we've got 180 degrees, okay? And we know that a triangle can't have more than 180 degrees. So that's why we're only looking at the top half of the unit circle, okay? But I want us to explore these 4 questions down here. So it says, example 1 says, find theta such that sine theta is 1/2. So if I look at my unit circle, okay, I might notice that, let's do this in pink, that sine theta equals 1/2 is the angle where the y value is 1/2. And that is right here, okay? That is in fact at 30 degrees. But I might also notice that this angle over here also has a y value of 1/2. This angle is 150 degrees, okay? So to answer example 1, find theta such that sine theta equals 1/2. I really want to say theta equals 30 degrees and 150 degrees. We have 2 possibilities, okay? All right, so let's take a look at example 2, all right? So find theta such that sine theta equals √2/2. Let's choose a different color, maybe orange, all right? And where on my unit circle do I have an angle that has a y value of √2/2? And it turns out that at 45 degrees, I have that. But if I apply the same reasoning that I did to example 1, it looks like 135 degrees also has a y value. So example 2 actually also has 2 solutions. Theta equals 45 degrees and 135 degrees, okay? All right, let's choose another color, maybe dark green for example 3. Find theta such that sine theta is 0.95. Now, 0.95 is not one of our usual nice y values, but really this means find theta with y value of 0.95, okay? So if we go up to our unit circle, hopefully remember that this has a y value of 1. So an angle that has a value of 0.95 is actually probably somewhere here, but then also somewhere over here, right? Let's see if I can get that to go nice and connected to the origin. All right, so now I don't know what these are, but let me see if I can use my calculator. And here's what I'm going to type into my calculator. Sine inverse. So we want to make sure we have that -1 of 0.95. And let's see what we get. Inverse sine of 0.95. And I get 71.805 degrees. 71.805, well, that is going to be this angle, right? 71.805 degrees. Okay, well, how do I find the other angle? Right? Our calculator only gives us one answer. How do I find the other angle? Well, let's think back to this pink one and the orange one, see if we can find a pattern, okay? I noticed that I got the 30 first, but if I do 180 minus 30, I get 150. Okay, does that work with the orange ones? 180 minus 45 is 135. Okay, so let's do 180 minus 71.805. I get 108.195. And that is the measure of the other angle. Okay, so here I have theta equals 71.805 and 108.195 degrees. Okay, and I got them because they should add to 180 degrees. Okay, all right, let's try one more. Let's get a different color. All right, find theta such that sine theta equals 0.2. So this means find theta with a y value of 0.2. Okay. And so I could use my calculator to do the first one. Let's see what we get. Inverse sine of 0.2, I get 11.537 degrees. Okay, so if I draw that on my diagram, 11.57 degrees, all right, that's going to be kind of down here somewhere. All right, 11.537 degrees. So where is the other angle that also has that same y value? Well, it's simply going to be the reflection on the other side, right? And how do we find this angle? We do 180 minus 11.537, and we get 168.463 degrees. So I'm going to go back down here and say that my theta can be 11.537 degrees or 168.463 degrees. Okay. Now, one last question that I didn't get into the examples, but I think is really important is this. Sine theta equals 1.5, right? This means, let's think about what this means. Theta is the angle that has a y value of 1.5. I don't see an angle on here with a y value of 1.5. This is 1. 1.5 is like up here, okay? So sometimes we get sine theta equals 1.5. That means there's no theta possible, right? No possible angle. All right, let me get this all on one page for you. Okay, so quick review of some important things on the unit circle. Come on back for part 2, where we actually take a look at some examples.